Hey, 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 fifth graders. Hey, it is Dr. Milam. Yes, 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 yes. Here is your video. I know I was supposed to post it yesterday, but here it is today. We are going to do lesson 29. We're almost at the end of this module. I'm only going to do one more lesson out of this module. Today is Wednesday, so I'm going to try and post it actually later on today for tomorrow. If I don't get to it, know that it'll be there first thing tomorrow morning. And then I'm going to go ahead and give you an assignment. I'm going to give you a measuring up. So you probably won't have a measuring up for today, but you're gonna have a longer one tomorrow, okay? Because it's gonna be like the end of the module, and so I'm gonna give you a little bit of an assessment, okay? And then Friday, I'm gonna ask you to go to two places because I want you to try it. One, I want you to go into Khan Academy, and I'm gonna assign you something, but don't look till Friday because I won't post it till then. And then Miss G gave you um, my own, which is like an online reading book, and I found something that was kind of cool on there. So I was thinking that I'd like you to do a little bit of a reading assignment about mathematics and sports. So I wanted to give you something very light for Friday. We're getting ready to go into spring break. Um, and you'll have an entire week off. For those of you who have not finished your assignments, you really have got to complete them because, like I said, you're going to have a new book. I am going to post something on Class Dojo about you guys coming to get your books. Okay, so they're going to be, matter of fact, I'm going to the school in just a few minutes after I finish this video to get your books ready. Okay, so you will need to go to the school and pick up modules 5 and 6. I'm going to give you both of them because we just don't know if we're coming back to school or not. Okay, all right, let's dive into the lesson. So this is lesson 29. The objective is to connect division by a unit fraction to division by 1/10 and 1/100th. And so really what they're doing in this particular lesson is getting you ready for fractions divided by decimals divided by decimals. Okay, so I'm just going to keep going on this because I want to start with the application problem today, because it's a little complex, but I thought it was also a little fun to think about, like reselling stuff. Okay. All right. So it says Fernando bought a jacket for $185 and sold it for 1.5 times what he paid. So I'm going to stop there before we try to read this entire problem because there's a lot going on. So let's read that again. Fernando bought a jacket for $185 and sold it for 1.5 times what he paid. So is that going to be more or less? It's going to be more, right? Because he sold it for how much it's worth, which is 185, and then half of that added together is going to be how much he sold it for. So you can think of it a couple of different ways because sometimes I know we don't always get the whole, like, am I multiplying, am I dividing, what am I doing? But if you step back to think about what the problem is asking, then you might be able to see it a little bit better. So I'm selling it for 1.5 as much. So that means it's going to be at least 185, right? And then what's half of 185? Well, half of that you would need to take 185 and divide that by 2. So 2 goes into 18 9 times, right? And so then this is 18. You've got the 5 left. And 2 goes into 5 2 times. 2 times 2 is 4. And so are you okay if I write it here? Because we're going to subtract. So 5 minus 4 is 1. Don't wig out on Dr. Milam. We need a decimal. And so we're going to bring that down. and then 2 goes into 10. I'm going to add that decimal at the top 5 times. So $92, well, 5 times 2 is 10, so we know that's going to give us a 0. Okay? All right, so $92 and really 50 cents, right? Because 92.5 in money is 52 cents. So we're adding that to this. We need a decimal here because we have to line the decimals up. When you don't see a decimal and a number, it's always behind the number. So it's like saying I can write $185 as $185.00. Okay? So I'm going to add these two together because remember it's 1.5. Okay? And so I'm adding those together. 5 plus 2 is 7. 9 plus 8 is 17. Carry your 1, and this is 2. So now if you notice that we got the same thing as they got here. So let's see what they got. They did 185 times 1.5. And if you notice, they took the 1.5 and they converted that into an improper fraction. Remember how to do that? It's this one here, your whole number, times your denominator plus your numerator. So it's 1 times 2, which is 2 plus 1 is 3. And then they multiplied these two together, which is the same, it's kind of the same thing here, okay? So they put this over 1, and then 185 times 3 is 555, and 1 times 2 is 2, and when you divide these two, you get $277.50. Okay, that was all for Fernando. Okay, so now let's see what Marsolo did. Marsolo, I don't know how to pronounce that. I know that Benea will help me later on in the comments section. Marisol spent 1/5 as much as Fernando on the same jacket. Wait, let's just take that for right there. She spent 1/5 as much as Fernando did on the same jacket. So guess what? She got a better deal because she didn't spend as much as he did. So maybe he bought his at Macy's and she bought hers at Kohl's or something like that. So let's see how much did she actually spend. So 1/5 of 185. So that's what they're doing here. They took 185. They're going to draw a tape diagram and break it up into fifths. And then this amount, 1/5, is how much she spent. Well, if 185 divided by 5 is how much? Well, if 5 units is 185, 1 unit would be what? You have to divide the 2. So she only spent 37 bucks. She got a better deal, okay? Now, so if you notice again, Dr. Milam is taking each one of these problems and she is breaking it down. She's not even reading the whole thing. And that's what I want you guys to do when you get to these problems. Don't try to do it all, okay? All right, so it says, but she sold it for half as much as Fernando did. So what did Fernando sell? He sold it for $277.50. Okay, so we're going to take his selling price. It says that she sold it, excuse me, for half as much as he did. So the amount that he sold it for, she divided that by 2. That's what this is doing. And this is the amount that she actually sold it for. So how much profit did she make? Well, $138.75 minus the 37 that she bought it for. That little girl, I tell you, she made a really great profit. Fernando needs to learn from her. All right. She made $100, a little over $100. Okay. All right. Let's move into our lesson. I actually want to walk through the language here from the teacher's note. I think it was really good. And then we'll do a couple problems together, and then I'll show you. Um, oh, did I bring the answers over? I didn't, but I'll do that. I'll do that on this video. I'll show you the answers of the problem set. All right. So the first problem that they want you to engage in, and let's just change the color because it just keeps us engaged. Let's do green. Okay. The first problem is 7 divided by 1/10. And so what Eureka wants you to do is think about uh, not 7 wholes divided by 1/10, but think about what is 1 whole divided by 1/10. So if you think about that in a tape diagram, if I've got a whole and I divide that into what? Tenths, because this is 1/10. 1/10. Okay? Whoops. This is 1/10. That's what this is. Remember, I'm saying it and I'm writing it. So if I were to take 1 whole, this is 1 whole here, and if I were to divide that into 10 pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I going to make it? I don't know if I'm going to make it. Let's see. Is that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I made it. So 1/10 would be this amount right here, 1/10. But they said that they don't have 1 whole, they have 7 wholes. Okay? How many tens are in 1 whole? Well, there are 10. There are 10 tens in 1 whole. Well, how much is that in 7 wholes? So just think about, I've got 7 of these things written. How many tens are in each one? There are 70. So let's look at what they did. So they rewrote 7 divided by 1/10 as 7 divided by 1/10, and they're saying that that's already 70. And they want you to think about it like this. Think about 1 whole. How many tens? How many pieces? How many tens can I get in 1 whole? It's like dividing that whole into 10 pieces. Well, I can get 10 pieces out of 1 whole. So that's where they're getting this from. There are 10 tenths in 1 whole. So how many tenths in 7 wholes? Because remember what this means. This means that I'm taking 7 and I want to know how many tenths are in 7. Does that make sense? There are 70 tenths in 1 whole. And if we do our keep change flip, you'll see that it's going to be right. So this is the same thing as 7 times. Remember, it's keep, change, flip. If we flip this, then this is what the math looks like for this. Okay. So 7 times 10 is 70. And then we know that this is over 1. And then 70 over 1 is the same thing as saying 70. Okay? So what Eureka wants you to do is think about this in terms of your unit fraction. And so you're going to see them ask you, well, not 7 wholes or 8 wholes or 19 wholes. They want you to think about 1 whole, how many of that fraction is in there, and then think about the whole that they're asking you for. Okay? Let's keep going. Okay? All right, now let's look at this one. This says that 7 4/10 divided by 1/10. So this is just like the problem that we had before. So you look at the language here. It says there are 7 wholes, but now there are 4 more tenths. So the whole in this problem is just 4 tenths more than problem 1. So instead of 70 tenths, there are now going to be 74 tenths. Okay? And we can ask ourselves, what is 7 and 4 tenths? 7 and 4 tenths is 1/10 of what number? All right, so let's look at what they did here. So they took 7 and 4 tenths and they turned that into 74 tenths. Well, you may say, well, how did they get that? Where did that come from? So I'm going to rewrite this. This is 7 and 4 tenths. Remember a couple of lessons ago, we went through how to change this. So we're going to do 7 times 7 times 10, which is 70, plus 4 is 74. Okay? And we already know how to do this because how many tenths are in 1/10? There are 10, and then my whole is 7. That's the same thing as this problem up here. How many tenths are in 7/10? There are 70. Not what's 7 divided by 10. That's not really what I'm saying. I'm saying how many tenths are in 7. I know that's so confusing. All right, let's just keep going. 7 and 4 tenths is the same thing as 74 tenths. Well, if you notice what they're doing here, divided by what? 1/10. Now you see that your unit language is already in tenths. So because you have the same language, oh, this is a setup for the next lesson. Because you have the same language here, you can just divide the numbers. So 74 divided by 1 is just 74. And then just bring your language along for the ride. So it's 74 tenths. And that's what they're doing here, although they broke it apart. They said there are 70 tenths and 7 wholes. There are 4, excuse me, need some water. I do not have Corona, stop it. I know you were thinking it. There are 4 tenths and 4 tenths. Yeah, that makes sense. And so there are 74 tenths and 7 and 4 tenths. Oh boy. All right, well, let's keep going. You can rewind that to walk through that. Okay, they're going to do a couple more problems. So let's do this. So 7 divided by 1/100ths. Look at that. So 7 divided by 1/100ths is the same thing as saying 7 divided by 1/100ths, which is 700. Okay, which is 700. Okay. All right, let's keep going. What about this one? We're dividing it by 7, 74 tenths. Look at the last problem for that. 74 tenths divided by, oh boy, 1/100ths. So you have to ask yourself, how many hundredths are in 7? Okay, there's still going to be 700. And now we've got 4 tenths more. Okay, if you do the math to it, this is like saying 74 divided by 10 times 100 over 1. Well, if I do the division this way, for those of you who see it, 10 goes into 10 one time, right? 10 goes into 100 10 times. And so this becomes what? 74 times 10, which is 740. Let's see what they did down here. Okay? So look at this. You could think of this the same way, and they actually didn't show the work here. Let's see. They didn't show the work. Well, I just did. It's right here. Okay. All right. So let's do this one really quickly. I thought I was going to show it. All right. So 7 and 49/100ths. Oh, this is good. 7 and 49/100ths is 749/100ths. Divided by 1/100ths. So ask yourself what this means for a minute. If I've already got hundreds and I want to divide, I only want one of those hundreds, how much is this going to be? Well, I have 749 hundredths divided by hundreds. That means that I have 749 of those. Then remember what this says. This says I'm going to take my hundreds and divide it by hundreds. Well, I already have hundreds. Well, how many of those do I have? 749. Oh, Lord, I know that that's so confusing. So I know you'll have to practice the language around this. I know that you'll get the math around this, which is 749 divided by 100, keep, change, and then flip it. If you notice that you've got 100 on top and 100 on the bottom, so 100 divided by 100 is 1, 100 divided by 100 is 1. So 749 times 1 is just 749. You may again have to replay that. Let's go right into our problem setup. I don't want the video to get too long. Okay? All right. So rewrite each expression as a division sentence with the fraction divisor, okay? And I'm also, when I do this, I'm going to give you a little bit of a preview to what the next lesson is going to ask you to do, which is what is the standard algorithm to this? But we're gonna tweak it just a little bit, okay? All right, so 2 divided by 1/10 is the same thing as 2 divided by 1/10, which is equal to 20, okay? So think about it like this. There are 10 tenths in one whole. How many tenths are in one whole? It's like saying I take a piece of cake and I divided by 10. I'm not going to do it. Oh, maybe I am. Divide this into tens. How many pieces do I have? That's basically what they're saying. Well, you have 10 pieces. You purposely cut it into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. I always seem to get to that last one and not have enough. If I take a whole piece of sheet cake and I divided it into tenths, how many tenths are here? There are 10. So there are 10 pieces of cake in one whole cake. If I divided it by 10 or divided by a 1/10, okay? So how many, if I had 2 cakes, how many tenths would I have? I would have 20 pieces of cake. That's basically what it's saying. And this language is a little different because 2 divided by 1 is 2. So that's a little different, or 2 divided by 10 is a little different than saying 2 divided by a tenth. That language is very, very different. These two have 2 different answers. This is actually 2/10. This answer right here, 2 divided by 10. And this answer, guess what, is 20. Those are 2 different answers, 2 different problems. Okay? So 5 divided by a tenth. How many tenths are in one whole? There are 10. So how many tenths are in 5 wholes? There are 50. So 5 divided by 1/10 is the same thing as 5 divided by 1/10, which is the same thing. Watch Dr. Newman. 5 times 10/1, which is 50. Okay, I'm adding this piece in there because I think that when you talk about the unit language, sometimes you guys can get confused with this, and I'm not with you. We've not been practicing this language every day by doing like our fluency or other things that I would have done And we're just not able to do it. Otherwise, we would have a 2-hour video because it would just be just like we were in class. So I don't want it to go that long. So how many tenths are in a hole? There are 10. How many tenths are in 8 holes? There are 80. I'm going to keep going. All right, now this one is a little different. There are how many tenths are in 5 holes? They want you to jump right to that. Well, there are 50. Now, if you need that extra step, like how many tenths are in one hole, here it is up here. And if you notice, these two problems are nearly the same. Okay, so there are what? How many tenths are in 2 tenths? There are 20 because there are 10 tenths in one hole. So that means there are 20 tenths in 2 tenths. Okay, so then how many there are, oh, I'm sorry. Wait a minute, hold on. Oh, how many tenths? Oh, I am so sorry, Dr. Marlon messed up right here because I knew I was getting ready to add that and that was not right. There are 2 tenths in 2 tenths. So when you add tenths together, you get 52. That language jumped for me and I didn't see that. All right, so that means that there are 52 tenths in 5 and 2 tenths. Okay? All right, so let's jump here. How many tenths, watch the language, are in 8 holes? So that means there are 80 tenths in 8 holes. Remember that there are 10 tenths in one hole and there are 80 tenths in 8 holes. That's the same thing here, okay? How many tenths are in 7 tenths? Well, there are 7. These are the same things here. So when we add these together, there are 87 tenths in 8 and 7 tenths. Okay, that's the same thing. If you don't see it, write it like this, and then you can see that there are 87 tenths in 8 and 7 tenths. Okay, I'm going to give you a little bit of preview right here to what we're going to do. So when you have a division problem, remember that you can actually write it like this. Again, this is a preview to tomorrow's lesson. Okay? All right, so this is like the same thing as saying what? What if there's a couple things here, but I think I'm just going to go ahead and show you. So if I multiply this, by, so this is tenths. If I multiply this by 10, what happens to the bottom and the top numbers? What happens? What is 10 times 1/10? I wonder if you know what that is. 10 times 1/10. Well, let's do it on the side here. 10 times 1/10. Look at that. When you see it like that, then you can see that that's the same thing as 10 over 10, which is equal to 1. So the bottom becomes 1. What about 5 and 2 tenths? If that multiply that by 10, if I want 10 copies of that, let's do that here. 5 and 2 tenths is the same thing as 52 tenths. Are you with me? And I'm multiplying that by 10. What happens? What's happening here? My 10s cancel and I've got just 52 left. So look at that. This is another way of thinking about how you divide decimals. So I get just 52. If you notice that 5 and 2 tenths times 10 shifts your number to the left. So that means that you get 52 on that hundredths chart, or you could think about it shifting to the right if you're just moving the decimal. Oh boy, Dr. Malum, really? Okay, let's do this one like that. So 8 and 7/10 divided by 1/10. If I multiply top and bottom by 10, guess what happens? 8 and 7/10 becomes 87. And 1/10 times 10 becomes 1. So this answer is 87. Same thing we got, same thing we got here. Wow, 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 wow. Let's go. Let's do the hundreds. How many hundreds are in one whole? There are 100. How many hundreds are in 5 holes? There are 500. And if we do the math to that, that's 5 divided by 100, which is the same thing as 5 times 100 over 1. And that's 500. All right, let's do it the way that I just showed you. So 5 divided by 100. If I multiply top and bottom by 100. Now, how did I know to multiply top and bottom by 100 as opposed to like 10? Well, what is this decimal? It's in hundreds. So 5 times 100 is 500. And then this is 100 times 100. 100 times 100. Well, that's just 100 over 100, which is just what, ladies and gentlemen, is 1. Look at that. So this is the same problem as this. So there's a couple different ways that you can think about it, okay? This is not 15. Remember that this was 5 divided by 100. Let's do it over here. How many hundreds are in a hole? There are 100. How many hundreds are in 8 holes? There are 800. And if I do the math like I did here, I'll find it. I'm going to jump down here to these decimals, okay? So there are how many hundreds in 5 holes? We just did that up here. There are 500. How many hundreds, are in 2/10? Well, how many hundreds are in 1/10? Let's see if we can go up here. How many hundreds are in 1/10? Did we do that problem? No, that's not on our page. How many hundreds are in 2/10? What do you think? What do you think? I'm going to give you a moment, see if you can come up with the answer to that. How many hundreds? You do it, you do it, you do it. How many hundreds are in 2/10? Think, 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 think. Yes, how many hundreds are in 2/10? I'm not going to tell you. I want you to think for just one moment. How many hundreds are in 2/10? How many hundreds? I know, Dr. Malin, really, seriously? 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 There are... Who has the answer? 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 There are 20. There are 20 hundredths and 2/10. You kind of can see what the answer is going to be here if you just go ahead and do the division, okay? So this is 5, this is 52 tenths. Woo! And also, you know what, I'm going to do it another way. So 2/10. I want to make that hundredths. Oh boy, look at this. Can I multiply the top and the bottom by 10? Doesn't that give me hundredths on the bottom? It does. Look at that. And 2 times 10 is 20. Ha ha ha. Oh, yes. All right, then. Let's keep going here. How many hundreds are in 8 holes. So let's say that you're here and you're stumped. You have no clue what to do. Go ahead. It's okay. You can do 87 tenths. That's what this is. Divided by 1 hundredths. So now that's a little different. So it says, let's keep going. Let's do the 87 times, 87 tenths, sorry, times 100 over 1. Okay? So, how many hundredths are in 8 holes? Do you know the answer quite yet? Well, let's keep doing the math of this because I think that is going to help you just a little bit. So 87 times 100 is how much? Well, that is, well, actually, let's do that. 87 times 100 is really just 8,700. Do you see that? Divided by 10. I might be confusing you. I think you get that piece of it. You get that piece of you might get that piece of it, but there are 800ths, 800 hundredths in 8 whole, and I was actually just trying to show you that here. I don't think it's working out here. And how many hundredths are in 7 tenths? Well, if there were 20 hundredths and 2 tenths, then that means that there are 70 hundredths and 7 tenths. Because I can take 7 tenths, and I could do that at the top too, and convert that into, I can convert that into hundredths. I don't know if that makes sense or not. By multiplying top and bottom by 10. If I do that, I get 70 over 100. So that's where I got 70 hundredths from. You could do the same thing here. If I've got 8 holes and I want to turn that into hundredths, I'd have to multiply top and bottom by 100. And that's why I get 800 from, okay? So that means that there are 870 hundredths in 8 and 7 tenths. All right, let's do it. Let's do it the other way that I was showing you earlier. So 8 and 7 tenths divided by 100. So all I did was write this problem as a division sentence. Okay, I know this can be kind of confusing. Okay, so I'm going to multiply top and bottom by what this is. This is how much? This is hundredths. So if I multiply it by 100, I know that 100 times 100 is just 1. And you can do that math on the side. I'm going to do it over here. 100 times 100. I'm kind of doing 2 lessons in one. This is like over 1. This is 100 divided by 100. Sorry, this is so messy today, which is just 1. So this is 1. Remember I said that I said it a few minutes ago, when you multiply by 100, it moves the decimal place, the number of, the decimal place, the number of hundreds that we have, okay? So this is saying I'm going to move the decimal place to the right 2 spaces, or I can think of it as if I'm multiplying it by 100ths, then that is how many hundredths. 100ths are in 100. There are only 1 of them. All right, let's do the top. 8 and 7 tenths. But if I'm multiplying this by 100, okay, I'm shifting my number on that hundreds chart 2 spaces. Can you visually see that? So if I'm doing that, that means my decimal, I should have brought the hundreds chart up. My decimal then is actually over here, because it's like saying I was here on the hundreds chart. So think about this as this is your whole, this is a 7 tenths. Are you with me? So think about this as ones. Oh, Dr. Malone, this is good. This is tens. Oh, this is tens. Let's think about this as hundreds. Hundreds with an S. Okay? So if I were to shift this, this means make this larger because I'm multiplying it by 100. So that means that this would shift 1, 2. So that goes over there. This will shift 1, 2. So that goes here. And I've got to add my anchor. Okay? So look, the decimal is here. Okay? I don't think I can put that there. It won't let me. The decimal is right here because it was 8. And remember that behind here is tenths, right? And then this would be hundredths and so forth. So this was 8 7/10. So this says make this larger. I'm moving it to the left, okay? So that's where we get the number 870. Okay? So 870. Okay, so let's keep going. I know that this might be a little tough. All right, so this is 6 divided by 1/10. You can go ahead if you want to right here and multiply top and bottom by 10. This is the new way of doing it, which is 60 over 1, which is just 60. Okay? Or you can think about it as 60 times, let's do it over here, 60 divided by 1/10 is the same thing as 6, I'm saying 60, it's 6. 6 divided by 1/10 is the same thing as 6 times 10 over 1. And do you see I'm still getting 60? So you decide which method. You decide which method works for you, okay? This is 18 divided by 1/10. If I multiply top and bottom by tens, by 10, I get 180 over 1, which is 180. Or I can think of this as 18 divided by 1/10, which is the same thing as 18, whoa, which is the same thing as, 18 times 10. It's the same thing, which is going to give me 180. 6 times 100. Oh, Dr. Miles did that in one step. We know the answer is going to be 600, okay? Let's do it. So 6 divided by 100 is the same thing as keep, change, flip, which is 600, or you could think of it as 6 divided by 100 and multiply top and bottom by how much this time? 100. So 100, this is not 7, this is a 1. 100 times 100 is 1. Okay? Let me do this one. Let's do this one. So 1 7/10 is the same thing as 17/10. So if I do it, okay, so let's do the 17/10 divided by 1/10. Are you with me on this? I could do keep, change, flip on this if I wanted to. So 17/10 times 10 over 1. And I need you to see that there's a 10 on top here. There's a 10 on the bottom here. So that means that these two are going to cancel. And I get just 17. If you don't see that, you can multiply it out. So 17 times 10 is 107, excuse me, it's 170 divided by 10. And 170 divided by 10 is still going to give you 17. Okay? Let's do it the other way. 17 1 and 17, but we got to change that. It's 17 tenths. And if I multiply, um, let's see, if I multiply that by 10, oh, this is, wait, hold on, divided by, wait, it worked here. Oh, I see what I did wrong. Okay. So I need to, oh, that's not going to work if I do that for you. Let me not show you that. Okay, I won't show it to you because you're going to get freaked out if I write it like that. Okay, so let's just keep going like this, okay? All right, so 374 hundredths divided by 100 is the same thing as saying 374 hundredths times 100, which is going to give you 374. Okay. The other thing is that, well, let me go back here for a moment. So it's 1 and 7 tenths. Let's leave it as a decimal over 1/10. If I multiply top and bottom by 10, okay, yeah, that works. So I don't want to confuse you. So 10 times 1/10 is just 1. 1 is 7 tenths times 10 is actually 17. Okay? And that gives you 17. Some of you are going to be way down on this one. Okay. It's 17. So there's the two ways to do it. Okay? Let's do that over here. So 12, you could think of 12 and 5 tenths as 125 tenths. Are you with me? Divided by 100. Oh boy, it's going to get a little confusing here. But let's do keep change flip right away because I know that some of you are like, all right. Times what? Times 100 over 1. Now you could do the multiplication, top and bottom, and then divide, but Dr. Mom's not going to do that. I can see that 10 divided by 10 is 1, and 100 divided by 10 is 10. So now I have 1 times 1 on the bottom, and what do I have on the top? I've got 125 times 10, which happens to be 1,250, and that's my answer. So you have to do what makes sense for you, okay? Let's do it the other way. So if I have 12 and 5 tenths, okay, divided by 100. So you said, well, what do I multiply top and bottom by? Which decimal? You're going to tackle this one, okay? So I'm multiplying this by 100 as opposed to multiplying it by 10 because I actually am trying to get rid of this. So 1/100 times 100 is just 1. You can do the multiplication. 12 and 5 tenths times 100. Remember that that's the whole, like, here is, there are what? 2 ones. This is ones, remember? This is tens. Right there. This is ones. So 12 and 5 tenths look like this on that hundreds chart. Now it says multiply by 100. So that means that you'd have to move it what? 2 spaces. So this is hundreds with an S. This is thousands. So I'm going to move this 2 spaces over. 2 spaces over. Whoops. Not physically. Move this 2 spaces over. 1, 2. So that's 5. But then now I've got to fill my ones in. So if you notice, you've got 1,250. Okay? So that's where I got this from. Okay, I'm going to let that marinate for a moment. Okay? And now I'm going to do the 2-word problems that are underneath here. Okay, so if you still need this, go ahead. I'll let you write it down, and then I'm going to get rid of it so I can do this word problem. Okay? All right, I'm going to get rid of this now. All right, so Young bought $4.60 worth of bubble gum, each piece. That's also an indicator that it's going to be division. Each piece costs 10 cents or 10 hundredths. How many pieces of bubble gum did he buy? So that means he's got to take $4.60 and divide that by 10 cents. So $4.60 divided by 10 hundredths, or 10 cents. So I could multiply this top and bottom by, what decimal is this? This is in hundreds. So I could multiply top and bottom by 100. So what happens when I multiply 100 times 10 hundredths? Careful. This is not 1 hundredths. This is 10 hundredths. So if this right here is the same thing as saying 10 hundredths. Some of you are going to be confused here, but I'm going to do it anyway. 10 hundredths times 100 is actually just 10. Okay, and I'll do it the other way in just a minute. 4 60 hundredths times 100. This right here is like saying, let's see. This right here is like saying 460 hundredths. Does anybody see that when I multiply that by 100, I just get 460? And then I can divide these two and I get 46. So that means that makes sense, right? He bought 46 pieces of gum and they each were 10 cents. Well, if they were $1, he would have spent $46. But they were not a whole dollar, they were only 10 cents. So he spent $4.60. Remember, we talked about the reasonableness of our answer. How do you do this, that standard algorithm? Well, $4.60 is the same thing. I can multiply that by what? Whoops, what happened there? Multiply it by what? Keep, change. I got to flip this. So this is 1/10. That's why you really need to write this as and I'm gonna write this. Let's see, let's get rid of that. I really need to write this as 460 hundredths. All I did was change this into hundredths, okay, in order for me to multiply it by 1/10. So I'm going to keep this, I just changed the form, times, careful, here we go, this is 10 hundredths, whoops, lots of marbles for my class. This is 10 hundredths, are you with me? 10, not 100th, 10 hundredths, okay? So I'm going to flip this, okay? So I get 100 over 10. So if you could see right away that 100 divided by 100, if you don't see it, multiply it across. 460 times 1 is 400. It's 460. And then I need to divide that by 10. That's not a G, that's a 6. And when I divide that, I get 46. I may have made this more complicated than it needed to be, but you get the problem. You get the picture. All right, we got 2 more problems to do. This was a short assignment here. So Cheryl solved this problem, 84 divided by 1/100. So this is different than this. So this is 10/100. This is 1/100. And I get 8400. Jane said your answer is wrong because when you divide, the quotient is always smaller than the whole amount that you start with. Well, that's not true. See, she's doing 6 divided by 2, which is 3, and then 100 divided by 4 is 25. But when you divide by a fraction, or you're saying I want to take this amount and cut it into itty bitty 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 parts, well, you're going to have a whole lot of itty bitty parts. And so that's why 6 divided by 2 is just 3, but 6 divided by a half is actually 12. So how did you, I don't get that, Dr. Mao. Well, 6, here's my whole. That's 6. And I'm going to divide that by 2. So first I've got to do 6. So 1, 2, 3, 4, 5. I did it again. 1, 2, 3, 4, 5. I fixed it. 1, 2, 3, 4, 5, 6. So now I have 6. Now divide that in half. What do you get? There are, how about we use a different color for that? There are 2 sets of 3. So I'm dividing it by 2. So I've got 3 in this part and 3 in this part. Or I could think of it as if I had 6 pieces of candy. 2, 3, 4, 5, 6. When I divide that by 2, I'm saying that I want 2 equal groups. And so there are 3 in each group. The moment, though, that I say divided by a half, I really want to know if I took my 6, I want to know how many halves. So that means I have my 6. Did she make it? 1, 2, 3, 4, 5, 6. Okay. So here's my 6. Okay. 1, 2, 3, 4, 5, 6. I'm asking how many halves are in each piece. That's what I'm saying. How many halves can you get out of 6? Well, here's a half, because I took each of my wholes and I'm dividing them. I want halves, so I'm dividing that by 2. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6 divided by a half is 12. 6 cut into 2 equal parts is 3. And so who is correct? They're actually both correct. Well, Cheryl is correct for sure, but Jane is only correct some of the time. So some of the time it's smaller. When you divide by a fraction or by a decimal, generally it's always bigger. But if you've got a fraction divided by a fraction, you really need to do the math in order to see. So let's see, is this actually 8400s? Let's see. So 84 divided by, let's see, which method do you want to do? Divided by 100ths is the same thing as 84 times 100 over 1. So I'm going to do a keep change flip. And if you see right away, 84 times 100 is 8,400 or 8,400. So Cheryl is right. Okay. All right, let's do the last one. Actually, I'm running out of steam here. I'm a little tired. The U.S. Mint sells 2 ounces of American Eagle gold coins to a collector. Each coin, weighs 1/10 of an ounce. how many gold coins were sold to the collector. Okay. All right. So the U.S. Mint sells 2 ounces of American Eagle gold coins to a collector. Okay. 2 ounces. Not 2 coins. Okay. 2 ounces. Yeah. Because I don't want you to just kind of methodically go through this stuff. All right. So it's 2 ounces. 2 ounces. Okay. So each coin weighs 1/10 of an ounce. So now we are talking about the same thing. So 2 ounces, all right, divided by what? 1/10 of an ounce. I'm just making that crystal clear that it needs to be the same unit. So this is in ounces, this is in ounces, okay? So it says how many gold coins were sold to the collector. Well, when we take 2 ounces and we divide that by 1/10, because each ounce, how many 1/10ths are in 2, tells us how many coins that we can get. So 2, keep, change, flip, is going to give us 20, and so there are 20 coins. Okay. Well, that concludes this. I know it was a little brutal, it was a little long. Do the homework is not that long. And I'm going to let you slide on your measuring up for today because I'm going to give you a longer measuring up tomorrow. Okay? All right. And I may just have that measuring up done, and then you can do it. I may even forfeit lesson 30. We'll see. I'll make a decision a little later on. But anyway, look for my post. Talk to you soon. Bye.